Welcome to this lecture on electricity in daily use. As you would have seen in the previous classes, we were talking about series and parallel connections. We have discussed this in the previous class, so today we will carry forward this discussion. So let me draw a typical circuit. I also hope that you would have gone through the material that I had posted on the Google Classroom, and also tried some of the problems mentioned in the PDFs that I had uploaded. So this is a typical circuit. So this, when you see this kind of a circuit, and this part is known as this is a voltage source. This is a resistor. This is a current source. Okay, so this point is known as a node, and so is this point, because all the 3 points are connected at the same point and there is no other element, no other resistor or any other element, so this is considered another node. Similarly, this is another node, since all of the 4 points are are connected without any circuit element, so this is known as another node. So if we say this is node A, this is node B, and this is node C. Now if you see, this is 5 ohms, let's say this is 2 ohms, and let's say this is 3 ohms. So this is any general circuit. So what I want to highlight in this is that node is a very important concept in circuit analysis. So node is any point where 2 or more circuit elements are joined. Okay, so it's a point of connection between 2 or more branches. So what is a branch? Branch represents a single element, such as a voltage source or a resistor. So this part here is called a branch. Similarly, this part here is also called a branch. Okay, this part here is also called a branch. So when you have a number of branches connected at one point, they form a node. Okay, so when you have nodes and branches, what results is a loop. If you see here, this closed path, this is a loop, right? Let me write this down for you. Loop, any closed path in the circuit. It's called a loop. So in this circuit, you can see that this is a loop, this is a loop, this is a loop. Similarly, you can see that this is also a loop, right? Similarly, this could also be a loop, right? And if you start from here, this could also be a loop, right? We will see about these in some time. Okay, so this is the concept of loop. We define a loop when there is any closed path in the circuit. Now let's see an example. let's say I have this. If I were to ask you how many, identify the number of branches and nodes in this loop, what would you say? What would your answer be? So let's see. This is one element, this is another element, this is another element, and this is another element. So there are total number of 4 elements in the circuit. So you have 4 branches. Okay, so you have 4 branches in this circuit. And what about nodes? How many nodes does this circuit have? This is one node, this is another node, these 2 points together form a node, and these 3 points together form another node, because there is no other element. So you have a, node B, or node C. So you have 3 nodes in this circuit. Okay, so this is a simple circuit. So okay, so if you are given any question, you have to identify the number of branches and the number of nodes. I think you can safely find that out. Now once you know this, once you have understood this concept of nodes and branches, we will further take our discussion and we will talk about what is known as Kirchhoff's laws. So these laws were introduced in the 1800s by a German physicist known as Robert Kirchhoff. So he has basically given us 2 laws which govern the circuits. So the first law is the Kirchhoff's current law, or KCL. So Kirchhoff's current law states that the sum of currents entering a node or a closed boundary is 0. Okay, so the algebraic sum of currents, you have to note this, algebraic sum of currents entering a node is 0. This is Kirchhoff's current law, or KCL for short. So mathematically, this means that if you have a number of n number of nodes, if you have a number of nodes, then we can say that the summation when n is equal to 1 to capital N, I of n, this is equal to 0. What does this mean? It means that in any given circuit, if there are n number of nodes, the sum of currents entering each node is equal to 0. If there are, if this is n branches and In is the current entering each node, where the small n denotes the node number, the sum of the current entering a node is equal to 0. What does this mean practically? Let me show you by a graphic. Let's say I have a circuit, any given circuit, where I say this is current I1, this is I5, this I say is I4, this I say is I2, and this I say is I3. So at this point, it says that currents entering the node, the sum of currents entering the node is equal to 0. So let's see, If I say what are the currents entering the node, they are I1. What other current is entering the node? I4 is also entering the node, and I3 is also entering the node. But if you see, currents I2 and I5 are going out of the node, so we can we say that they are leaving the node, right? We can say that they are leaving the node, right? And hence they have a negative sign associated with them. So currents, if you say that the currents entering the node have a positive sign, the currents leaving the node have a negative sign. So if you arrange this term, if you arrange these terms, you can safely say that currents entering the node, that is I1, I3 and I4, is equal to currents leaving the node. I2 and I5 are leaving the node, so we can say that currents entering the node is equal to currents leaving the node. Okay, this is an alternative form of KCL. What is it? Sum of currents entering a node is equal to sum of currents leaving the node. Okay, so this is the simple statement of KCL. Okay, so let's take an example of a circuit. Let's say you have, this is a current source with a current of I1. The arrow denotes the direction of the current. So what is this? What can you say about this current IT, which is the current leaving this node? So if you say, you can think of these 3 points, you can think of this as one node. So can you say that at this node, if you apply KCL, what do you get? IT is going out, right? I2 is also going out. So can you say that IT plus I2 is equal to I1 plus I3? Can you say this? Yes, because IT, this current, and I2, these two currents are going out of the node, and currents I1 and I3 are going into the node. So based on KCL, we can derive this relationship between the 4 currents. Okay, so then we can say that this total current IT, which is the resultant current, that is in fact equal to I1 plus I3 minus I2. So this is the statement of KCL. The second law that Kirchhoff has given us is the KVL. You would have studied this in your higher secondary classes, but I still want to repeat them here. Kirchhoff's voltage law. And this basically says that the algebraic sum voltages around a loop is 0, right? So if you have sum of voltages, if you have m voltages in a loop, the sum of voltages in that loop is equal to 0. Okay, so let's see a simple circuit. You have, let's say you have now note that And the polarity of this let's call it V1 and let's call it V2. The polarity of these, by polarity we mean the orientation of the plus and the minus signs. The V1 and V2 is fixed, so you cannot change that. But for the resistors and other elements, you can give you the polarity yourself, and if you further analyze the circuit, then you can sort of make a conclusion about whether your assumption was right or wrong. So if I say that this is positive and this is negative, and I call it V2, and I say this is positive and this is negative and I call it V3, what does KCL tell me? It says that the sum of voltages around a loop is equal to 0. So what can I do? I will see the voltages, and for this you have to remember that when you see a rising potential, let's say by rising potential I mean if you're going from minus to plus, you can call it negative, and falling potential, plus to minus, you can call it positive. What do I mean by that? That means if I start from this point here and I go to this point, I will say that this is minus V1, and then I'm going from this point to this point, so positive. I'm going originally, if I'm starting from point 0, I'm going to point number 1. It is a rising potential, so I take it negative. It depends on you how you want to solve it. So 0 to 1, it's minus V1. Then 1 to 2, it's a falling potential, so I take it as positive. Then you have 3 here. 2 to 3 is again positive. Then 3 to 4 is again rising, so you take it as minus. And we haven't labeled this, so we can label this as well. Let's call it V5, and let's assume that this is the polarity. And V5, 4 to 0 is falling potential, so you take it as positive, and you say that according to KVL, the sum of voltages around a loop is equal to 0. I will repeat what I said. So when you go from negative to positive, you say that this is minus V, and if you go from plus to minus, you say that this is plus V. This will be clear when you solve some problems and examples. So I am supposed to calculate the voltages across the different elements. So if I rearrange the terms, I can simply say that V2 plus V3 just a second. Oh, sorry, this is not V2, this is V4. So if I rearrange the terms, I can say that V2 plus V3 plus V5 is equal to V1 plus V4. Okay, so the sum of voltages around a loop is equal to 0, or you can say that V2 and V3 and V5, these are all, if you see, what is V2? V2 is basically voltage drops, because you are going from positive to negative, so we can say that this is a voltage drop. And V4 and V5 are V4 and V1 are voltage rises. You are going from minus to plus, so this is a rise. So another statement of KVL would be sum of voltage rises is equal to sum of voltage drops. Okay, so this is the simple statement of KVL. Okay, so let's see an example here. If you are given three voltage sources connected like this, where this is V1, this is V2, and this is V3, and you are asked to calculate the voltage between point A and B, and you are told that this is VAB. So what will this be? Okay, what will this voltage VAB be? So let's say I'm going around in the loop like this. So even though this is not a loop, I can think of this as a loop, and I can find out the voltages between this point and this point, and I can go around this part, and I can say that minus VAB, since this is a voltage rise for me, VAB plus V1 plus V2 minus V3 is equal to 0, right? So then if I rearrange the term, I can say VAB is equal to V1 plus V2 minus V3. So this is the voltage between the points A and B, VAB, like this. Okay, so this is the voltage between points VAB. Okay, so this is the simple illustration of Kirchhoff's voltage law. So let's take a circuit and try to solve it. Suppose you are given a voltage source which has a voltage of 20 volts and a 2 ohm resistor and a 3 ohm resistor. You are told to find out the voltages V1 and you have to find out the voltages V2. So I am giving this convention over here. I am saying that give me this voltage, V1 indicated like this and V2 indicated like this. So what should I do? Let's see. So in this circuit, if I make a loop, I can go around this loop and apply KVL. So I'll say minus 20 plus, if I say that a current I is flowing in the circuit, because there is only one path, so this is a series circuit, I will apply KVL and I also make use of Ohm's law. I will say minus 20 plus 2I, because at across this V1, what is the voltage across V1? It is equal to I into R, right, according to Ohm's law. So I is the same, R is 2 ohms, so this V1 is going to be plus 2I. And what is the next? What is V2 going to be? V2 is going to be, so this is a 4 voltage rise, so I'll take it as minus 3 into I, and then I'll say 0, right? So what is this? So minus times I equals to 20, or I equal to 20 ampere. So what does this tell you? This tells you that the current just a second, let me one more time for you. I'm sorry for this confusion. If I have if I go around this loop, I can say that this is minus 20 volt plus V1 minus V2 equal to 0, right? So what is this V1? V1 is equal to I into R, where I is the unknown. So I can say that it is minus 20 plus 2 into I. And what is this V2? This V2 is basically, if this is the current I flowing in this, so it is 3 into I. So this minus V2 is actually equal to this plus 3I. So it is like this. The direction is opposite, but if I see the current, if I see the flow of current, I can simply say that this is like this. So 5I equals to 20, and I equal to 20 by 5 is 4, so 4 ampere is the total current that is flowing in the circuit, right? So what is V1 now according to this? So V1 is equal to I into R, so that 4 into R is 2, so this is 8 volts. And V2, what is V2? V2 is equal to minus times 3i, because the polarity here shown is opposite, right? It is not shown in the correct, not shown, but I'm not saying it's not shown in the correct way, but the polarity is opposite. So V2 is minus 3i, so V2 is actually equal to minus 4 times 3, so it's actually minus 12 volts. So when I say that V2 is actually minus 12 volts, this actually means that the correct orientation of this voltage is plus 12 here, like this. So if you have 8 volts over here and you have 12 volts over here, they together sum up to form 20 volts between points A and B. I hope you have understood this. So this is the simple example of using Ohm's law and KVL and KCL on a circuit. Now, one thing to note here is that this V1 and V2, the one V1 and V2 shown in the green, I have given this convention by myself. I have said that I assume that the 2 ohm resistor has a voltage V1 like this. What the polarity of this is, this resistor is going to be, will be decided by the current and the resistance. Okay, so when I have to see any circuit element, I can show the current like this, or I can show the current going like this. Okay, so in this previous circuit, I'll redraw this circuit again. So let's say in this circuit, if this is 20, this is 2 ohms, this is 3 ohms. Okay, so let me say that current I is flowing like this and the same current is flowing like this. So if I go around this loop, apply KVL, it's going to be minus 20 plus 2i plus 3i equals to 0. Okay, alternatively, if I take the voltages, and if I say that this is V1 and if I say this is V2, so I can also say that minus 20 plus V1 minus V2 equal to 0. Okay, so this is what I was trying to make you understand. So here you can clearly see that V2 is equal to minus 3i. Why it is so? Because actually the current direction that I'm showing here across this 3 ohm resistor, I am saying that the current is flowing like this. Okay, so if the current is flowing like this, the actual potential is going to be plus and minus. But what is the V2 that I have defined here? It's minus plus. Okay, so this is the V2 that I have given you, and this is the actual polarity when I assume that current I is flowing in this direction. Okay, so this will be clear, this confusion will be clear when you solve some more problems. I'll give you some problems to solve, and if you solve them, practice them at your places, I think you will be able to solve these circuits with ease. I'll give you another example right now. So let's say I have let's say a 32 volt battery and a minus 8 volt. This is 4 ohms and this is 2 ohms. Okay, I am told to find this voltage V1 and I am also told to find out this voltage V2. Okay, so let's apply KVL on this and let's assume that the current I is flowing like this. Okay, so if I go around this loop, I can say that minus 32 plus 4 into I and minus 8. Why is this minus? This minus is because I am increasing the potential, right? I am increasing the potential. So just a second, this is minus 32 plus 4i and this is minus 8 is the voltage here, minus 8 volts, like this. This is minus 8, and then I have what is next, 2i. So this is equal to 0. So what is the sum? So this 6i is equal to 6i is 6i is 40. So I is equal to 40 by 6. Okay, so just a second. Oh, wait, I made a mistake somewhere. I made a mistake somewhere. Yeah, I made a mistake. This is not supposed to be minus 8. This is actually plus 8. I'll show you how. I'm sorry for this mistake. See, even I can make mistakes. So this is minus 32 actually. Minus 32 going this way. Then you have plus 4i. Then when you go up this like this, so it is minus times, because you're going from minus to plus, you have minus. And then what is the voltage here? It is minus 8 volts. And then you go plus 2i, that is equal to 0. Okay, so what is the current here? It is 6i, and 32 minus 8 is equal to 24, right? So I is equal to 4 amperes, isn't it? So what is V1 going to be? It is going to be 4 into I, it is going to be 16 volts. And what is V2 going to be? It is going to be 2 into I, it is going to be. Now note here that when you say the polarity is positive and you say the current is like this, this is actually going to be minus times 2 into I, so it is going to be minus 8 volts. Okay, this is, I think I have discussed this in one of the classes, that if you have current flowing like this, the polarity is like this by convention. Okay, and if you have current flowing like this, the polarity is the opposite. Okay, so you have to keep this in mind when you are solving such problems. Okay, so this is plus V and this is minus V. Okay, so you have to keep this in mind when you solve some more problems. This confusion will get cleared, of course. So with this we come to the end of this discussion on KVL and KCL. Now I will give you some more problems to solve at your places. I hope you are able to solve them. And the last thing that I wanted to talk about is power. By power, when we talk about power, we basically talk about power in DC circuits is the product of voltage into I, voltage into current. So if you have any circuit, let's say you have a circuit like this. So what is the current in this circuit going to be? I, it's going to be V by R according to Ohm's law. It is 20 by 5, it's going to be 4 amperes, right? So if the power in the 5 ohm resistor is going to be the product of the voltage across the resistor into I. So what is this V across this 5 ohm resistor going to be? It's going to be I into R. So if I is 4 ampere into 5, so it's going to be 20 volts, right? So what is the power going to be? Power is going to be V into I. So it is 20 times I of 4 is going to be 80 watts. So the unit of power is watts. So here it is 80 watts. Okay. So this is how we define power in DC circuits. We simply say that power is the product of the voltage and the current in DC circuits. Okay. So with this, we come to the end of this lecture on KVL and KCL, and also we have talked about power. In the next lecture, we will talk about alternating currents, and we will finish this unit number 1 of this course. And I hope you will solve some more problems, and when you solve some more problems and practice these questions, you will be able to understand it, and you will not face any difficulty while solving any questions that may be asked in the examination. So I'll see you in the next lecture.